Good morning. Today I am going to explain lead acid batteries topic. In my previous video, I explained about what is lead acid cell, what are the chemical reactions in lead acid cells during charging and discharging, and chemical reactions in nickel iron cells during charging and discharging, and finally chemical reactions in nickel cadmium cell during charging and discharging. Today, the main objective of this video lesson is constructional details of lead acid battery, means parts of lead acid battery, and going to explain active materials of lead acid cells and suitable materials for separators and containers are going to be explained. Then lead acid cell parts. This is the practical picture of lead acid battery. The battery which uses sponge lead and lead peroxide for the conversion of chemical energy into electrical power. Such type of battery is called a lead acid battery. The lead acid battery is most commonly used in power stations and substations because it has higher cell voltage and lower cost. Coming to the construction of lead acid battery, the various parts of lead acid battery are shown in this figure. The container and the plates are main parts of lead acid battery. The container stores chemical energy which is converted into electrical energy by the help of plates. The open view of the lead acid cell parts are brought outside, and each one, the first one is called grid plate, and the second black colored one is called positive plate. After that, microporous separator, latter negative plate. This is only one plate. All positive cells are connected to one connection site and all negative cells are connected to other sides. It is a pack. The most inexpensive secondary cell is the lead acid cell and is widely used for commercial purpose. The positive plate lead peroxide PbO2 and the negative plate lead Pb are immersed in dilute sulfuric acid. When the cell supplies current to a load, means discharging, the chemical action takes place and forms both plates lead sulfates with water formation in the electrolyte. The positive plate and negative plate and electrolyte are called active materials. To charge the cell, direct current is passed through the cell in reverse direction to that in which the cell provided current. This reverses chemical process and again forms a lead peroxide on positive plate and a pure lead on negative plate. At the same time, H2SO4 dilutes sulfuric acid at the expense of water, restoring the electrolyte to its original condition. The EMF of lead acid cell falls during discharging and increases during charging. The lead acid cell should be recharged when the specific gravity falls to 1.18. A lead acid battery is a collection of number of lead acid cells connected in series. The most common are 6 volts type and 12 volts type. 3 cells are connected in series. In case of 6 volts type, means each cell developing 2 volts. 3 cells are connected, 3 into 2, 6 volts. 6 cells are connected in series in case of 12 volts. 6 into 2, 12 volts. Container of lead acid cell is the main part of lead acid battery. The container of the lead acid battery is made of glass, lead lined wood, ebonite, the hard rubber of bituminous compound, ceramic materials, or molded plastics, and are seated at the top to avoid the discharge of electrolyte. The purpose of container is to house the plates, separators, and electrolytes. At the bottom of the container, there are 4 ribs. On 2 of them rest the positive plate and other supports the negative plates. The material of which the battery containers are made should be resistant to sulfuric acid, should not deform or porous, or contain impurities which damage the electrolyte. Again, it may be made of glass, ceramic, celluloids, or transparent synthetic plastic materials. Celluloid containers are used for portable wireless set batteries. If the battery used in automobiles, a more robust material is required to prepare a container to withstand mechanical shocks. Container is sealed off at the top to prevent the spilling of electrolyte. A large space is left at the bottom of the container to allow the sediments drop from the plates. This is the figure of container. Another figure of the container. Sample of containers. Next, the most important material of lead acid cells is plates. Plates of lead acid cells. The plates of the lead acid cell is of diverse design, and they all consist of some form of a grit, which is made up of lead and the active material. The grit is essential for conducting the electric current and for distributing the current equally on the active material. If the current is not uniformly distributed, then the active materials will loosen and fall out. The grits are made up of an alloy of lead and antimony. These are usually made with the transverse rib that crosses the places at right angle or diagonally. The grit for the positive and negative plates are of same design, but the grits for the negative plates are made lighter because they are not as essential for the uniform conduction of current. A plate consists of a lattice type of grit of cast antimonal lead alloy, which is covered with active material. The grit serves as support for fragile material and conducts electric current. Positive plates are usually planted process, whereas negative plates are pasted type. Negative plates are somewhat lighter compared to the positive plates. This figure is the view of plates and separators. You can see this is positive plates group and this is negative plates group, and these are separators. You can see this is plates groups and this is only one plate. A collection of these plates will be added to one group, and the plates of the lead acid cells are positive plate groups and negative plates groups are of two types. They are formed plates or plantate plates and pasted or for plates. Plantate plates are generally for positive plates, and for plates or pasted plates for negative groups. Plantate plates are used largely for stationary batteries, as these are heavier in weight and more costly than pasted plates. But the plates are more durable and less liable to lose active material by rapid charging and discharging. The plantate plates has low capacity weight ratio. For process or pasted plates is much suitable for manufacturing of negative plates rather than positive plates. The negative active material is quite tough and it undergoes a comparatively low change from charging and discharging. And you can identify that the positive plate is dark chocolate in color, then this is belongs to positive plate, and the negative plate is sponge lead, and the other plate is obviously is negative plate. A commercial cell contains an odd number of plates such as 11, 13, 15 or 17. The number of negative plates is always one more than the number of positive plates. This makes both sides of positive plates to be used actively, but also the tendency for one side of the plate to distort is balanced by a similar effect on the other. Separators is another important part of lead acid battery. The separators are thin sheets of non-conducting material made up of chemically treated lead wood, porous rubbers, or mats of glass fiber, and placed between positive and negative to insulate them from each other. Separators are grooved vertically on one side and are smooth on the other side. Separators, thin sheets of electrically insulated porous material used as spacers between the plates to prevent short circuit within the cells. Fine pores in the separators allows ionic current flow in electrolyte between the positive and negative plates. The important characteristics of separators are uniform plate spacing, oxidation resistance, high electrical resistance, porosity, pore size distribution, wet ability, and good acid diffusion. Permeability, specific surface area, mechanical design and strength, ionic conductivity, and chemical comparability are the important characteristics of separators. Separators are grooved vertically on one side and are smooth on the other side. The grooved side is placed against the positive plate to permit free circulation of electrolyte around the positive plate, where greater chemical action takes place. Mainly the materials used to make separators: cedar wood, rubber, glass fiber mat, cellulose, sintered PVC, microporous PVC or polythene, microporous plastics. AGM type of separators for wall-regulated lead-acid batteries. Suitable for industrial and motorcycle applications. PG separators for industrial applications. These are the figures. Vent plug or filler caps. Vent plug are provided at the top of the cover for allowing the electrolyte to be added when required. Vent plugs are made of polystyrene or rubber, usually screwed in the cover. The function is to prevent escape of electrolyte but allow the free exit of gas. Vent plugs can be easily removed for topping up or taking hydrometer reading. What is hydrometer? I will explain in coming video lessons. bottom grooved support blocks. These are raised ribs either fitted in the bottom of the container or made with container itself. Bottom grooved function is to support the plates and hold them in position, and at the same time protect them from short circuits that would otherwise occur as a result of fall of the active material from the plates onto the bottom of the container. Battery terminal post. You can see the figure for the battery terminal post. It is upward extension from each connecting bar which passes through the cell cover for the cable connection to the outside circuits. Each cell has two terminals marked as positive and negative. Negative terminal post is smaller in diameter than the positive terminal post. This is to identify which one is negative terminal post and which one is positive terminal post. Connecting bar. It is the lead alloy link which joins the cells together in series. It connects positive pillar of one cell to the negative pillar of next one. Next, cell cover. You can see this is the cell cover. Cell cover has a hole into which is fitted with vent caps. These all are vent caps. Vent cap has vent hole to allow the gases formed inside the cell. Till now, I explained various parts of lead acid battery. Active materials of lead acid cells, suitable materials for separators and containers. And coming to the active materials, the materials in a cell which takes active participation in a chemical reaction during charging or discharging is called the active materials of the cell. The active elements of the lead acid are 1. Lead peroxide, PbO2. It forms the positive active material. The PbO2, lead peroxide, are dark chocolate brown in color. 2. Sponge lead. It forms the negative active material. It is gray in color. Third active material, dilute sulfuric acid, H2SO4. It is used as an electrolyte. It contains 31% of sulfuric acid. The lead peroxide and sponge lead, which form the negative and positive materials, have little mechanical strength and therefore can be used alone. Means lead peroxide for positive active material, sponge lead for negative material, dilute sulfuric acid, or these three are active materials of lead acid battery. During chemical action discharging, the anode is of lead peroxide and cathode is of metallic sponge lead, fully charged condition. And now these two are ready for discharging. When the electrodes are connected through a resistance, the cell discharge and electron flow in a direction opposite to that during charging. The hydrogen ion moves to the anode and reaching the anodes receive one electron from the anode and became hydrogen atom. The hydrogen atom comes in contact with PbO2, so it attracts and forms lead sulfate, which is in whitish in color, and water according to chemical action. And chemical action during recharging. For recharging, the anode and cathode are connected to the positive and negative terminal of the DC supply mains. The storage battery or secondary battery is such a battery where electrical energy can be stored as chemical energy, and this chemical energy is then converted to electrical energy as and when required. The conversion of electrical energy into chemical energy by applying external electrical DC source is known as charging of battery. Whereas conversion of chemical energy into electrical energy for supplying the external load is known as discharging of secondary battery. During charging of battery, Current is passed through it, which causes some chemical changes inside the battery. These chemical changes absorbs energy during their formation. When the battery is connected to external load, the chemical changes takes place in reverse direction, during which the absorbed energy is released as electrical energy and supplied to load. Please remember, during discharging, both plates are converted into PbSO4, lead sulfate. The specific gravity of sulfuric acid solution falls due to formation of water during reaction at PbO2 plate. As a result, the rate of reaction falls, which implies the potential difference between the plates decreases during discharging process. During charging process, lead sulfate anode gets converted into lead peroxide. Lead sulfate of cathode is converted to pure lead. Terminal potentials of the cell increases. Specific gravity of sulfuric acid increases. This is about the summary of lead acid battery constructional parts. Thank you very much for watching my video lessons. Thank you.